Hello everyone. Today I'm going to share you regarding IGCSE Physics paper 6. Yeah. This is paper 6 on year 2019. Yeah. Yeah. This is IGCSE Physics. Mm, yeah. Physics year 2019. This one, yeah. So this is actually from student. I use as the exam or mock test. Yeah. So let's check together. Yeah. If I have a mistakes, please give me advice or anything. Yeah. Okay. Let me check. Start from number one. Student is investigating moments using a balancing method. Figure 1.1 show the apparatus. We have meter rules, we have bands, we have pivot, and we have two meshes P and Q. Yeah. Okay, the student places the metal without the load and the pivot and adjusts its position so that the metal is as near possible being balanced. She keeps the rule at this position on the pivot throughout the experiment. Yeah. Explain briefly why the position on the pivot may not be exactly at 50.0 centimeter marked on the rule. She asks me as the center of gravity mass is not at the center. Yes, yeah. The center of gravity mass is not on center. Okay, that's correct. Mm. Okay, then she placed a load P on the metal roll so that sorry the edge that the further from the pivot is exactly at the 10.0 centimeter mark on the rule. She measured the distance between this edge of the load P and the pivot source as shown in figure 1.1. She places a load Q on the meter roll and adjusts the position of load Q so that the meter roll is as near as possible to being balanced. Yeah. She measures distance B between the center of load Q and the pivot as shown in figure 1.1. Table 1.1 or figure 1.1. Oh, this one, yeah. She repeats the procedure with the edge the load P that furthest from the pivot at the 15.0, 20.0, 25.0, and 30 centimeters. Yeah. All the readings are shown in table 1.1. Oh, they have table. Yeah. This is A in centimeter on the left side and B in centimeter on the right side. Okay. Done. Check next question. Oh, this is the question. This is the table. Yeah. Okay, this we give one more. Yeah. This and this. Yeah. One mark and then this pointing one mark also and best fit one mark also. Yeah. Yeah. They get 0.4. Yeah. Okay, so C question determine the gradient G of the graph. So clearly on the graph how you obtain the necessary information. Yeah, gradient is y over x. Yeah, maybe Yeah, you can find by a triangle, yeah, on this line. So delta y, this is delta x. Yeah, delta y per delta x is gradient. Yeah. Get okay. Use 20, 20 and 25. Oh, maybe this one. This is 25. This is 20. Okay. Determine the interrupt C on the first curve. This value 1.2 centimeter. What is gradient? This is 0. Why 1.25 here? This is 0. So maybe if this like so maybe 1 point something. No, not correct. Yeah. Okay, then measure width W of the load B. Yeah, no, it's okay. 2.4. Use the ruler. Yeah. Then another student suggests the value of intercept C should be equal to half and width W, and the load P state whether result supports suggestion. Justify for your answer by reference to result. Either support or not support. That's okay. It's the message that it's okay. Yeah. Yes, it's hard to keep the pivot in the same place in the position. Yeah, okay. Okay. Yeah. Question 2. We have about 4 questions. Yeah. Let's check question 2. I use the mark scheme to compare with this answer to the right answer by Cambridge. Yeah. 2A. Okay. 2. A student is investigating the rate of cooling of water under different conditions. A greater rate of cooling occurs if there is a greater change in the temperature during the same period of time. Figure 2.1, Figure 2.2 show the apparatus used. Beaker A glass lid. Beaker B in the metal made of the same material as lid. The mat and the lid have the same thickness. Okay. Yeah. Figure 2.2 and Figure 2.1. Yeah. The thermometer in Figure 2.3 show the room temperature theta R. The beginning, the experiment record theta R. Theta R is about 23 here. 23. So the answer. Oh, sorry, 22. It's correct. Yeah. 22. Correct. Then B question. The student pours 200 centimeter cubic of hot water into beaker A. He places the lid on the beaker and places thermometer in the beaker as shown in Figure 2.1. He records the temperature theta of the hot water in time t0. He immediately starts the stop clock. He records the time and temperature readings every 30 seconds until he has 6 sets of readings. He repeats procedure user beaker B. The beaker is on math bus, has no lid. All the readings are on table 2.1 and table 2.2. Okay. Yes, this is beaker A on the left side and beaker B on the right side. Yeah. Complete the column heading table 2.1 and 2.2. Oh, they don't need any mark. Yeah, this is T in second and theta in degree Celsius. Yeah, second degree Celsius. Then look carefully at the reading table 2.1 and the table 2.2. Tick the box to show your conclusion from the readings. Okay, on the maxim is third box ticket to match reading. This is correct here. The first box, the lid reduce the rate of cooling of water significantly more than the mat reduce the rate cooling the water. No. The mat reduce the rate cooling of water significantly more than the lid reduce the rate cooling of the water. There is no significant difference between the lid and the mat in reducing the rate cooling water. So you can see this is not a significant difference here. Start 83, 81, 87, 80. This is not difference significant. Justify your conclusion by reference to the readings. Say answer the temperature only drops for 1 degree Celsius every 30 seconds for each table, and beaker B only hotter by 2 degrees than beaker A from every 30 seconds. Until yes, but same thing maybe. Yeah. It's okay lah, it's okay. Then question C. A student plans to repeat the experiment using same apparatus and the same volume water. Suggest one thing to the procedure that will decreases the rate cooling at water. Increasing room temperature. Yeah. Increasing room temperature. Increase in room temperature. Higher, yeah, maybe higher. It's okay. Higher room temperature. State one precaution that must take order to record accurate temperature readings. Make sure you fix thermometer at eye level. Oh yes, correct. Perpendicular, yeah, viewing of thermometer. Suggest two variables that must control in order to make experience fire tests. Initial temperature of water, the size of breaker. Initial temperature. Starting, yes. Same breaker, yes. Okay. Size, same. Okay, that's correct. Yeah. Then it is important to view measuring cylinder correctly to obtain the accurate value of volume of a liquid. Tick the box that gives best description of how to read a measured cylinder. The line offset should be along the scale. No need yet. The line set should be vertical. The line set should be right angle to the scale. No, that's correct. The line should be parallel to the scale. Yeah. It's correct, yeah. Take third box. Okay. Oh, question 3 about electricity. A student is investigating electrical resistance. She used the circuit shown in figure 3.1. Okay. The power supply, ammeter, resistor P, lamp L, and then voltmeter parallel with resistor P. Write down the readings of meter figure 3.2, 3.3. Yes, this is 3.6. Yeah, okay. Correct. 0.3. Yes. Okay. Then, okay. Our next page. Calculate the resistor R1 of the resistor P using equation R equals to V1. Okay, 12 ohm, correct. The student connect the voltmeter across the lamp. She record the potential difference V2 across the lamp, 2.4 volt. Calculate the resistance R2 of the lamp using equation R2 V2 divided I1. V2 is 2.4 and I1 is 0.3. So equals to 8. It's just 2.4, yeah, divided 0.3. So 8, yeah. It's not correct. Not 80, but 8 ohm. The student replaced the resistor P with the resistor Q. She record the potential difference V3 across the resistor Q and current I2 in the circuit. V3 3.5, I2 is 0.31 ampere. So calculate the resistance R3 of the resistor Q using equation R3 is V3 divided I2. Yeah, just 3.5 divided 0.31A. So this is about 11.29. Yeah. Good. State whether result R1 and R3 suggest the resistor P and Q have the same value of resistance. Within the limits of experiment accuracy, justify your statement referring to your result. Yes, resistor P and Q of R and R2 is the same. Yes, it's about 12 ohm. Yeah. Because the result R1, R2 is not too far off each other. Okay, good. Then next question, next pages is on the E. The student connect the voltmeter across the lamp L. She records the potential difference V3 across the lamp L. V4 is 2.5 volt. She calculates the resistance R4 of the lamp is 8.1 ohms. She suggests that the change in resistance of the lamp from part C is due to change in the temperature of the lamp filament. Suggests an observation that she could make to confirm that the temperature of the lamp filament changes. What is this? It is about brightness, is correct? Yes, brightness or intensity of lamp changes here. Correct. F. Complete the circuit in figure 3.4. Two resistors and the lamp are connected into parallel. Yes, correct. This is in parallel. Yeah. The voltmeter is connected to measure the potential difference across the resistors and the lamp. Yes, correct. Yeah. Okay, then G. State the name. Yeah, so they get point to you. State the name of circuit component that you would add to circuit you have drawn to the control the current of circuit. Variable resistor. Yes, correct. Yeah. Good. Next. Whoa. Wow. Check next. Oh, they have. It's okay. Okay, read first the question. Yeah, a student investigating. Yeah, student investigating the relationship between the thickness of converging convex lens and its focal length. Figure 4.1 shows the cross section of a converging lens. The focal length f of lens can be calculated if u, the distance between the object and lens, and v, the distance between the lens and the image on the screen are known. The equation is f equals to uv divided u plus v. Okay. Plan an experiment to investigate the relationship between the thickness t and the focal length f of converging lens. You may add figure 4.1 as the part of the answer. Yeah, later you need use this drawing. Your following apparatus available to student: illuminated object, selection of lenses of different thickness and lens holder, screen, meter rule, 30 cm rule, 2 rectangular wooden blocks with longer side, longer than the diameter of the lenses. In your plan, you should draw a diagram to show the arrangement of apparatus labeling U and V. Yes. Explain briefly how you would carry out the investigating, including the measurement and will take. Explain briefly how you will determine the thickness T of each lens. You may draw a diagram if it helps your explanation. Draw a suitable table with column heading to show how you would display your readings. You do not need to use the equation to calculate focal length. Okay, let's check student work. Okay. First thing they show us about diagram. Yeah, that's correct. It's okay. They get 1 mark. It's 1 mark. Then U and V correctly labeled diagram. Okay. This is 1 mark. Okay. Set up, make sure you have different thickness lens, measure lens thickness living between wooden block and measure the same using ruler. Record every value view. Oh, this one they get 1 mark. Yeah. Count the focal point for HTC. Okay, they have 10 bar. Repeat with different lenses. Okay, they have 1 mark. For repeating, they have 1 mark. This block is a lens measure distance. Okay, they have this distance they have 1 mark. So method obtaining sub image by moving lens on screen. Oh, this is, they get 1 mark also. Table with column U, V, yes, but table is also 1. So total mark is 7. Yeah, they get 7 mark. Let's get this one. Okay, I think that's it. I will calculate. I will adding any score here. Yeah. Thank you very much for watching this video. Don't forget to subscribe. Don't forget to like and inform to the other if this video have benefit to you all. Thank you very much. Bye.